Hello, my name is Hugh Thorby, and I've been interested in reproducibly sharing uncertainty in model parameters. I've been thinking about this for a little while, and this is what I've come up with. So my first question is, are there existing standards that I can make use of that will make it easy for me to share? And yes, of course there are. Is CellML, SBML, and I'm particularly interested in the SBML distrib package, and ZML, so I can really connect my CellML and my SBML together. Now, all of these are part of the Combine standards, and what's nice about that is they already come with the omics meta data, so that I can combine all of these things in a single archive and make it shareable. So the question then is, can I use these tools? Can I make something using these standards? And of course, without a tool to make use of these standards, it makes life very difficult. CellML has libCellML, SBML has libSBML, and you probably guessed what ZML has, but it has libZML. And the omics meta also has a library as well. So all these things are available from a programming point of view, so I can interact with them. So that's all looking promising. And the question really left is, do I need to do any hand waving to connect all these together and put them into a libomics metadata? So I'm a bit of a practical thinker, and so I decided to do some work towards this and see how far I could get. And I created this web application for seeing exactly what I could and couldn't do. We'll take a look at this web application and see what parts were successful and what wasn't. So here is my web application running. It's running in the local browser, just locally on my machine. And it's fairly basic. It has just a few things up here. What we're really interested in here is the simulations tab. So I need to prepare a simulation to get it to run. So the first step is really making use of the CellML model, and that's quite easy. I have a lot of access to CellML models, and I've chosen to look at this Harudi SIPA model. Now this is version 2. It's taken the version 1 of this model and converted it into CellML 2.0. So this is the updated model. Nothing really has changed too much in that model. It's just been updated to the latest CellML standard. So I've preloaded this model. I'm going to select it here and load up the model. I'm going to extract some of the information from it, like the parameters that I may not be able to set. So this here shows me all the parameters that are available to me in the model. There are quite a lot. I'm really interested in the this channel here. I'll see if I can find it. So if I select that, you should be able to find down here somewhere. No, can't see it. It's quite a lot of parameters. There it is. So that's just, I just selected the one parameter. This is one I'm going to add my uncertainties to and see what effect it has on some outputs. So from there, now that I've selected this parameter, I can set the distribution that I want to apply to it. That's what I'm going to sample from. So there's only the one parameter that I've selected, and these are all the distributions that I could choose that are available to me from the SBML distrib package. So I've just setting it up with a normal distribution. I've taken no notice of whether this is actually a practical decision. It's just really experimenting and seeing if I can make it work at all. So the mean there is just taken from the model and just a sigma just to get some variation going. Once I've set my distribution for my parameters, I can then look at describing the simulation. This is where I'd like to see the ZML to come in and save some of this knowledge. So if I can just set up and save my parameters in the ZML, that's what I would need to do. I'm not currently doing that right now. It's sort of the next stage in this. And with that, I can now set up, I can now look at the outputs that I want to get from my simulation. And I just want to look at my membrane potential. So this is, again, something that I have already loaded up. And I think that is right down the bottom somewhere here. So there's the membrane potential there that I want to get as an output. So with all that set, I should be able to run there. I should be able to simulate that. So the job is running, it's just running locally on my computer. So I'm generating the code from the CellML. I'm using SBML distrib to sample the parameters, and then I am not using ZML to describe that and run it from the ZML. So I can, now that it's finished, I can look at the plots and see what I get out of it. So I've loaded up, I've only really done quite a short sample here. I've only just done the one beat, and we can see here that I've got quite a bit of variation in my membrane potential for different parameters, for different values of my input parameter. So that's quite pleasing. It shows a good deal of what I want to see, but some of the, I guess, the bad things, I'm not looking at using ZML very well to do this. So what did I get from this exercise? Well, I managed to use libcml quite nicely, generate code from a CellML2 model, and I was able to set it up so that it could accept some external parameters. I would like to add uncertainty into the whole simulation process, but at the moment I am just adding uncertainty into the initial values of the model simulation. I also used the SBML distrib quite successfully, where I could define a distribution and sample from that distribution using libSBML. I didn't manage to use ZML. I didn't quite get there in terms of what I was working on. Hopefully I will get that working and see exactly what I do and don't have from capabilities from the ZML. And I didn't package it up at all. So I got about halfway there, I guess. still some things to work on, but I think the idea itself for me works as long as I can describe what I want in ZML, so others can then replicate, reproduce what I have done here. So there's a few acknowledgements to make. A lot of this work is done by other people. There's a lot of links here for anything that, for all the parts that this bit of work has been based upon. Interested to talk to people about how we can, how other people see sharing uncertainty model parameters. Thanks for your time.